So for each identity, we're going to first verify an identity for one angle, and then we're going to prove the identity. So this is important for us to understand the difference between these two words. We've got verify in one question and prove in the other. And as far as our method for solving these is going to be very, very similar. What verifying means is they want you to check, is the left side and the right side the same if you plug in a certain value? So the way that we'll set this up is very much like a proof. We'll set up our left side and our right side. We'll plug in the value of 30 degrees. So we'd have secant of 30 degrees times by 1 plus cos of 30 degrees. That would be on our left side. And on our right side, we have 1 plus secant of 30 degrees. And it becomes a unit circle question. How do we figure out what secant of 30 degrees is? Well, we know cos of 30 degrees, root 3 over 2. So secant of 30 degrees will be 2 over root 3. And I just said cos of 30 degrees was root 3 over 2. And same thing on this side, we get 1 plus 2 over root 3. Now currently, these don't look the same. We have to come up with simplifying this with algebra, often that idea of writing things as a single fraction in simplest form is going to work. In this case, if I distribute my left-hand side, can you see that 2 over root 3 times 1 is 2 over root 3? And 2 over root 3 times root 3 over 2, can you see that the 2's would simplify, the root 3's would simplify, and you'd just be left with 1. And so simplifying on the left side and simplifying on the right side, once they're the same, you have verified it. And you can say, therefore, the left side is equal to the right side. So sometimes what happens with mathematicians is they've got an equation, they plug in a value, and they're like, oh, they're the same. And then they wonder, are they always the same? So a proof is showing that something always works. So if I was, this is part I, verifying, if I wanted to prove it, again, I would write out the original equation, secant theta times 1 plus cos theta equals, and on the right side I had 1 plus secant theta. Again, for our proofs, same thing, where the equal sign is we draw a line, and now we have to use our skills in manipulating both sides to see if we can make them match. Okay? And so one of the things you might do in the first equation is change or multiply this through. And we get secant theta plus secant theta times cos of theta. And at this point, usually what we've done so far, one of the main strategies we've used is changing everything to sine and cos. Okay, so I could change all of the secants to 1 over cos. But in this case, I'm looking at it and I know that I can also change cos to 1 over secant. If I change my cos to 1 over secant, and this is secant over 1, rules of fractions, those would simplify. And then I'm just left with secant theta equals 1. So I have proved it as well. QED. Nice. I'm going to give you some scrap paper because I'm going to get you to verify part B and prove part B. I'll put up the answer for the verify for part B and the proof, left side. Tan of 30 degrees is root 3 over 3. So in this example in particular, they currently do not match up, so I am going to write both sides as a single fraction. On the left side, to get it a single fraction, I need a common denominator. That'll give me 3 minus root 3 all over 3. On the right-hand side, I have fractions inside of fractions, so I'm going to get a fraction in my numerator. So I have a fraction over a fraction. That will leave me with 3 minus root 3 all over root 3 divided by 3 over root 3. Now that I have a fraction over a fraction, I can multiply by the reciprocal. This would get grouped together, so nothing will simplify there because the minus sign groups those things together. But I do have a root 3 and a root 3 there, so that can simplify, and sure enough, my left side is equal to my right side. So again, do we have the fraction skills to write both sides as a single fraction? Because if we do, we're going to be able to verify and prove. Comes out to about 90% of this unit can be done just with those methods. Just our fraction skills. So we're going to practice them over and over again. Yeah? Yeah. Now, the proof is much more powerful because if you prove it, well, it means that it works for every angle, 30 degrees included. So the verify only shows one thing works. The proof shows everything works. So again, we rewrite it out. Okay? And in this example, when looking at it, I could change everything to sine and cos. I could change tan to sine over cos. I could change cotangent to cos over sine. And that has been one of our main strategies so far. However, in this example, looking at it, I can see that I can change everything to cotangent if I want to, or I could change everything to tangent if I want to. And having everything in one trig function like that will likely mean that we can easily prove it. So proof, method 1. I'm going to change everything to tangent and see how it goes. Changing everything to tangent means that I have fractions inside of fractions on my right-hand side of my equation. And so once again, I'm going to want to get a single fraction on the top, multiply that 1 by tan theta over tan theta. One thing that I like to do when I'm doing my proofs is I like to leave a little bit of space in between, because you have fractions inside fractions, and if you squish it all together, you might just think one thing runs into the other. So it's important that you leave a little bit of space. So here I'm going to get this together on the top. Now that I have a common denominator, it's 1 over tan theta over tan theta. I like to use a bigger, thicker line for my main part of my fraction. Okay? The second thing in proofs that students often do, which causes them to either get the wrong answer or to lose marks along the way, you can't just do part of the work. You might get annoyed rewriting something that you know is going to be there and you just want to simplify the top. but each line has to equal the line above it. And if something happens in a line that doesn't equal the line above it, even if you correct it afterwards, it's a deduction every time that you do that. So I have to rewrite the bottom and make sure that what I wrote here is equal to what I have above. And now I have a fraction divided by a fraction. So I can multiply by the reciprocal. This one gets grouped together because of the minus sign, but this factor and this factor are identical, so they can simplify. And I get 1 minus tan theta. Therefore, left side is equal to the right side. And we're done. Okay. How many people change cotangent to tangent? Couple. How many people change the tangent? I'm going to erase this, because this is the other thing about proofs. You can do them in multiple different ways, and those multiple different ways are right. How many people change the tangent to cotangent? Did anyone do that? So if I change the tangent to 1 over cotangent, and then again have this idea, can I get this to be a single fraction? I would need to multiply this 1 by cotangent over cotangent. Then I get a common denominator. What's the top going to be? Well, cotangent theta minus 1. Oh, we're done. That was even quicker. And you could have also changed everything to sine and cos and got a single fraction. And it would work as well. So sometimes there's quicker methods versus longer methods for our proofs. Okay, our questions for this one are 3, 5, 6, and 7 part II only.